Hey guys, now let's discuss a new question, which is what is LLM? So LLM is a large language model. Okay, so for example, OpenAI's GPT, and then Anthropic Claude, Google Gemini. Okay, so here an LLM is basically a very advanced next word prediction machine. Okay, this is the important thing, next word prediction. So it is doing nothing. You just have one model, you have one machine where we have trained that machine with a huge amount of data, and now when you search something, it will just predict the next token, next word for you. That's it. Okay, so for example, you know that in here in RAG or in AI, we store information in the form of numbers, okay, which is called embeddings. So for example, if you have something called text, so you will not store it directly like text, plain English term. Okay, you will store it something like 0.21, 0.11, and different dimensions you will have. Okay, and in the form of, so this is the vector. Now let's say text and book you have. Okay, textbook, so you have book, so book will have the similar vector array only, so something like 0.19, 0.10. So can you see this, that they are similar? See, this is 0.21, this is 0.19. Okay, so it will do semantic it will do similar search for you, and then will return next word as book. So if I'm typing text, so it will return me book, because its a vector is means similar. Okay, so that is the thing here, and this is how LLM works. That's it. It is just one model. Okay, and we have trained that model with huge amount of data, and then when user query, it will just find the similar word, semantic word for it. It will do semantic searching and then will return the response to you. So now an LLM, basically a very advanced next word prediction machine, trained on huge amount of text. LLM works by converting text into numbers, understanding pattern using transformers. Okay, now how it is just finding the similar pattern, similar vector. See, you have a lots of data, something like this, so he cannot go and do linear search for you, right? So you have some transformers, some neural networks you have, and using that it will just find the similar vector for you. Okay, next it will predict next word for you, and predict the next token repeatedly to generate human-like response. And repeatedly it is doing that, not only one word it is predicting. After predicting one word, second, third, fourth, and then it will form a sentence and then paragraph and then return you something like that. So for example, suppose you type I drink coffee every. Okay, so the AI predict the next word like it should be morning. That's the core idea. LLM continuously predict next word, the next token, and the next sentence. Right? Okay, very fast. So high level flow of LLM, if you see, so let's say you have the user has typed something, okay, some question. So what is the capital of France? So first it will get converted into this text into tokens, like what is the capital of France? Okay, it will break into the tokens and then convert tokens into numbers. Okay, so these are called the embeddings, because system understand these numbers, and then it will go to neural network. Okay, so neural network process this pattern. Okay, what is the pattern here? And transformer, you can say transformer is a large neural network. Okay, and looks all the numbers, understand the context and relationship, and then predict the next token, and then generate response token by token, like the capital of France is Paris and dot dot dot. Okay, and then you will get the final response. So this is the normal flow of LLM. Now step by step explanation, if you see, so this is user gives the input like what is the capital of France. So the second step is tokenizing. Okay, LLM does not understand words directly, it breaks text into small pieces called tokens. For example, what is France? Okay, whatever we just saw in the diagram, we are just seeing here. Okay, think tokens like Lego blocks of language. Now convert tokens into numbers, which is called embeddings. Computer only understand numbers, so tokens becomes a vector. Okay, for example, France will become something like this. Words with similar meaning have a similar vector. Okay, that is what I told, we saw that 0.21, then 0.19. So for example, if you have words like king, queen, prince, okay, so they will have the same vector only, similar vector. Okay, because they are related to the same pattern, vector pattern. That's why. Now neural network understand context. Okay, this is the main intelligence part here. So LLM uses the huge neural network called transformer, and important concept here is attention mechanism. So this is the very important thing in the transformer, attention mechanism. So here the model figures out which previous words are important. So this is the only concept. Example, if you are writing like animal didn't cross the road because it was tired. So here what is the meaning of it? It is it could be animal or it could be road. So he will understand the previous word, okay, which is important. So here it refers to the animal, using attention. Okay, so how it is doing it? Using attention. This is the main important thing. So now predict next token. Now model predicts next token. Example, like input you have the capital of France is, so it will predict Paris. Okay, so then continue processing Paris, and then it is also known for something like that, all the other sentences. Now generate final response. So response is generated token by token very quickly. Okay, so for example, token 1 Paris is the capital. Okay, and then user will see that response. Now what happens during training time? You need to train these models, right? So before chatting with user, LLM trained on books, internet, Wikipedia, code, articles. Okay, all sorts of data we have given, all sorts of information we have given to these models, and training objectives predict missing next word correctly. So for example, the sky is, so he will predict blue. Okay, billions of such prediction train the model itself. Now why it is called large? Okay, large language model, LLM. So large means because it has billions or trillions of parameters. Okay, this is the one thing, parameters. Then second is massive data sets and huge GPU cluster. Now what is GPU here? Okay, so GPT model have billions of weights. So for example, GPU like GPT, like we use, right, OpenAI GPT. So they have the billions of weights there. Now what is GPU? First let's talk about GPU. There is two things, CPU and GPU. Okay, so GPU is graphics processing unit. It is a processor. Assigned to perform mainly calculations simultaneously. Okay, so originally GPU was built for graphic rendering in games. Okay, birds. Okay, so originally GPU were built for graphics rendering in games, but today they are heavily used for AI, ML, deep learning, LLM training, scientific computing, and video processing. Okay, so popular GPU companies are Nvidia, AMD, and Intel. Now if you see the difference between CPU and GPU, so CPU is very few powerful cores. Okay, it will have different cores, right? 8 core, 32 core CPU you have seen. So good for operating system, API, databases, business logic. We wanted to perform these kind of processing things. So you will use CPU there. Like for example, 8 to 32 powerful cores if you have. So you will use their CPU. But now GPU is thousands of small cores. Okay, so this is very huge, and it is good for parallel computing, then matrix operation. Okay, so here you can see vectors, and then you need to perform dot product, and then cosine similarity you need to find. So all these kind of calculations you need to do, right? So to find the similar words. So matrix operation is important here. Okay, and then AI training inference. So for all these things we use the GPU. Like for example, 5,000 plus lightweight codes one GPU can have. Okay, now important concept. So context window. Okay, this is the main thing, context window. You know that in RAG video also I told you that we see first what user is answer. User is searching for something. Okay, so he has asked one question. So we will have our database, vector database, where we will find the documents relevant information, and we fetch that relevant information from that vector database. It could be document, not the complete if the document is very big, then we will divide that document into chunks and just retrieve the relevant chunks only. And now these relevant chunks plus question we will send to LLM. Okay, there you will have a neural network transformer and all, and they will do a semantic search for you and return answer for you. So this is the simple mechanism, simple flow, okay, of that. So here why we are doing that chunking part, because the context window for LLM is limited. Okay, so you cannot send the huge context there. You have to send the relevant context only. So that is the context window of LLM. So LLM remembers only limited recent text. Okay, so for example 8K, 32K, 128K tokens. So this is the limit. Now like short term memories, Now, next thing is hallucination. So, what is hallucination? Sometimes LLM confidently gives you wrong answer. Why? Because it predicts the next text and not the truth. Okay, so it is simply just one machine which is predicting next word. That's it. So where LLM are used, so you can use that in chatbots, okay, ChatGPT, coding assistant like GitHub Copilot, and then search AI like AI search engine, then translation, language conversion, or content generation like vlogs or emails. So this is the LLM. That's it. Thank you.